All right, this is going on page 86 when we are done. Starts with, so far in Unit 3, we've learned how to define sine and cosine values. Remember, they have to be in standard position. We're measuring the angles in radians, and we're using the unit circle. I know I keep giving you empty promises about being at the door, but that's because I wanted to do warm-ups. I want to do activities. I'll be at the door again. It'll be when you least expect it, and you better know those angles. So what we're thinking of here is we're looking at sine as a function of theta. Like we are used to functions happening. If you think about the unit circle is a function, but it's technically called a parametric function. Your higher level sciences, you'll use that. Cal 2, which means if you're taking BC, you'll talk about parametric functions. But if we think about our x and y values on here, our x is cosine or y is sine, right? But aren't we used to x being input and y being output? That's not what's happening here, right? Your input is theta, and then your output is x, and another output is y. That's what makes it parametric. All you need to know is it's like not a normal function, right? So that what we did just now is we split them into a function of sine and a function of cosine, okay? We can leave this table blank because that is, I was just gonna fill that in, but I already put the points there because this is what you just did on your transparencies. There's no need to repeat that, okay? So this is your theta is your input, sine theta is your output, okay? Now, I want you to look at one more thing. This is something I did during COVID because we couldn't do any kind of activities. Your quadrants. We talk a lot about quadrants here. We have quadrants here too. We don't care about those, all right? When I talk about quadrants 1, 2, 3, and 4, I'm talking about the unit circle. So if we look at how this gets drawn, sine is positive in the first quadrant. There I am at pi halves. Positive in the second quadrant. Then sine is negative, negative. That makes sense? Okay, so here's cosine. Cosine, we know everything's positive in the first quadrant, right? Then cosine is negative in the second quadrant, negative in the third quadrant, positive in the fourth quadrant. Okay, these are the quadrants that are important to you. So on here, this is what I want you to do. I want you to draw a vertical line at pi halves, one at pi, and one at 3 pi halves. Okay, because we're chopping this up. I know you understand x and y like this, and I know you understand those quadrants, but we have to wrap our minds around how this all connects to the unit circle. So from 0 to pi halves, that is quadrant 1. Then from pi halves to pi, that is quadrant 2. This is quadrant 3. This is quadrant 4. Okay. Does that make sense to you? Okay. So if I'm asking you like, what quadrant am I in right here? The answer is not quadrant 1 because of this graph. I'm in quadrant 2 because it's 5 pi 6. Okay. Thinking unit circle. Are we good with that? Questions? All right, let's talk about some terminology. We already talked about the transformations here, which you've been doing transformations forever, right? And so this is a horizontal translation, just like Valdo said beautifully. And the exact same things happen, but with trig, some of the vocabulary changes just a little bit, but it's not that big of a deal. First of all, midline, we talked about a teeny tiny bit the other day. It came up and I said, we hadn't officially talked about it yet. It's called the midline. It's in the middle. It's not that hard. So that's what it is. The midline is halfway between the maximum and minimums, and it is a line, keyword line, so it's y equals 0 for the parent function. That's this right here. We use it kind of like we do asymptotes. It's officially not part of the graph, just like an asymptote isn't, but we sketch it in because it helps us figure things out a lot. Okay. Then we've got amplitude. Amplitude is the distance from the midline to the maximum or minimum. Here, this is the amplitude. It's 1. Where else have you heard the word amplitude? Physics, okay. Yes, absolutely. Where else in the real, I don't want any more trauma, so where else in the real world? What? Electricity, you got amps, right? If you play an instrument, why might you need an amp? Yeah, I don't know that it tunes it, but you're on the right track. It makes it louder, right? Like if you have an amp and an electric guitar, right? That's a little bit I know about music. So I want you to see this before we finish that part up. Actually, we'll talk about one more thing, then we'll do that. The period is 2 pi. We also talk about frequency. We talk about period more in pre-cal, frequency more in like physics and the sciences. This means it takes 2 pi units to get one cycle. This means you have one cycle in 2 pi units. You see how it's really the same? It's just how you talk about it. So I want you to see this. Okay, if you have, look at this amplitude as far as sound waves are concerned. Because, by the way, all of these are sinusoidal functions. They're all sine waves because you can make cosine into sine. Quieter has a smaller amplitude, louder has a larger amplitude. Then look at this, a lower pitch and a higher pitch. That's your, when you're squeezing together, and your frequency, talking about hertz. Okay, so if you've ever looked at a sound wave or looked like a voice wave when you see that, those are all sine waves, okay, all of them. And let's see, I want one more thing before we finish up, because I know the bell's about to ring. And then the word oscillates. We'll talk about cosine tomorrow, but oscillates between concave up and concave down. Y'all had some amazing discoveries in that little activity, so thank you very much for that. Tomorrow we'll talk about cosine, and we'll finish this up because we are using our sine and cosine with the unit circle, right? Yes, we are. And do you need to know those values? Yeah, just leave the transparencies and my pins there. I'm going to do my best to be at the door tomorrow, and y'all don't disappoint me. Okay, so let's kind of revisit some of what we did yesterday. I gave you all the little toothpicks that were cut. This is actually what y'all said because I just saved the last one. Asked you to be able to tell me what each color could have meant. There were multiple answers. I didn't write up here the horizontal and vertical displacement because I was kind of running out of room, but those are words that we use. I really like, and I've said this all day because y'all were the first class where people gave me like not just first quadrant stuff. So when whoever it was said sine of pi fourths, or it could be sine of 7 pi fourths, and some of y'all are like, oh no, because one's positive and one's negative, but because it was a little toothpick that we could move somewhere else, it could totally represent both. And then whoever gave me the answer about the blue, you didn't, you didn't even give me first quadrants, but these totally work as well, right? The length itself of those things are technically positive numbers because it's a length, but you can use it to represent the negative, okay? Because I wanted you to physically have it from the unit circle to put on the graph to see that they are the exact same things. I think that kind of helps with the connection. Then y'all make graphs that look like this. Of course, mine is not that accurate. In hindsight, I should have actually had it drawn on there so it could be accurate and pretty, but I'm off some, but you get the idea of that. And then with your transparencies, I asked you to tell me how we can make one into the other. So I can either take sine and translate it to the left, or I can take cosine and translate it to the right. Either way, I'm literally doing the same thing with transparencies, just depends on which one I'm moving. But we could completely ignore cosine, and anytime we have to write an equation, which we will get to eventually, we could make everything into sine, but there's reasons that cosine makes things easier as well, okay? So now I'm going to kind of go back over the first part of the notes here. We were here on page 86, okay? And these points were already on there for you because that's what you had just done on the transparency. I didn't want you to have to go back and redo that. And you could fill in those boxes if you want to. But I want to remind you again, that if we're talking about quadrants and I ask you which quadrant this 4 pi thirds is in, you're not going to say fourth because that point is literally in the fourth quadrant. It is, but I don't care. When we're talking about quadrants, 4 pi thirds is in the third quadrant. You think about the unit circle, okay? That makes sense because that's where some people get confused. So I'm going to kind of repeat that a bunch. If we're talking about quadrants, you should be picturing the circle in your head so you're not confused, okay? And that's why we split all that up. Then we talked about the some of the vocabulary. Midline is literally in the middle. Keyword is line, so it's a y equals. We can't just say that it's 0. Amplitude is the distance from the midline to a maximum or minimum. Period is what we use more in pure math. That would mean it takes 2 pi units to go one cycle. Frequency you use more like in the applications or in the the true sciences, where it would say you get 1 cycle in 2 pi units. They say the same thing, it's just kind of you talk about it differently. But one is just the reciprocal of the other. And then the sine graph, it oscillates between concave up and concave down. And I think that's kind of what somebody said on those graphs when I asked you what was the same, what was different, that sort of thing. Something about, it changes from concave up and concave down. So all that stuff was fabulous. What I want you to write on here, though, remember when we did all of our other functions last semester, I said that it's important that in certain times that we actually have a little sketch of a parent function. So I want you to draw this, because if you have to have a little sketch of a parent function that is sine, that's what you're going to draw. And if you get mixed up between sine and cosine, all you have to do is ask yourself, what is the sine of 0? And hopefully you can answer that question. And then you would know that it would be this one. Okay? Mm-hmm. It's not whatever he said yesterday. I don't remember what it was, but let's not say it. All right. Are we good on all that so far? Okay. All right, let's flip this over. So now here's cosine. We didn't get this far yesterday, right? Okay. So here's cosine. Same thing. You can fill that in if you want. That was really more if we hadn't done the transparencies, we could fill that in and I could tell you how to estimate this stuff. But this is what you did on your transparency for cosine. So this is theta, comma, cosine theta, right? And again, quadrants, we're thinking about the unit circle. The properties and the definitions are all the same, which should make sense because these are the same, just shifted over, right? So for cosine theta, midline is still in the middle. We treat it like we did with asymptotes. It's not actually part of the graph, meaning just like an asymptote, that's why we put a dotted line. It's not, we don't really have a line there. We don't really have a line here, but it kind of helps us figure the graph out, especially when it gets a little weirder. Amplitude is this distance or this distance, okay? Amplitude is 1, and I think I had time to show you this yesterday. The sound waves, where if it's quieter, the amplitude is smaller. If it's louder, the amplitude is bigger, and you're amplifying something, right? As far as sound waves are concerned. And pitch, lower pitch is a stretched out graph. A higher pitch would be more squeezed together. Okay. And so back over here. All right. Again, period and frequency, same thing, and we oscillate. If you have to draw a parent function for cosine, 1 cycle of the parent function of cosine is going to look like that, because it starts up here. You don't have to make it all like long and stretched out. It's whatever. It's enough for us to do things on it when we need to wrap our mind around it. Okay, we all okay with that? Now, one thing I'm pretty sure I said at the end, but I think I might have been yelling at you while you were packing up, that both sine and cosine are both sinusoidal functions. Okay, there's no cosinusoidal. Sinusoidal function is any function that involves additive and multiplicative transformations of sine of theta. So sine and cosine are both sinusoidal functions. And then we know that, we know that, just like I said before, you can take to get cosine, I can take sine and move it to the left pi halves. That's what this says right here. Or to get sine, I can take cosine, and which direction would I have to move cosine to make it into sine? To the right, which means this would be minus pi halves. Now, could I move it to the left also? Yeah, I can move it to the left a different amount, or even to the right a different amount. There's an infinite amount of answers there. But those are the closest and the most common if you see it or use it on anything. Just like x was a liar, theta and x are good friends, because theta is our default for angles, and theta is a liar too. Okay? We're good so far? Questions about any of that? All right, I'm going to play you literally a 30-second video to show you some sound waves. The sound is not even good, which I think is kind of funny that you're going to make a little video about sound waves. And I thought maybe it was just me, but everybody else agrees. Well, it just, I feel like, I don't know. I mean, yeah, y'all can decide. Fine with me. Right, but listen, because again, it's really short. Like, that's not that bad. So it's going to show what they look like for 3 different instruments. I know a lot of y'all are in music stuff. So there's looks like a trig wave, right? Not as simple as what we have, but. I'm not even sure if they're all the same notes. Maybe they are. I don't know. But clearly the way the sound comes out, the sound waves are different. And so I wanted you to see that and that they look like that. I graphed just something random to show you something else that isn't just a pretty curve. We're really just dealing with the pretty curves in pre-cal, like if I do sine of x or cosine of x. But here I graphed sine of 2x plus cosine of 3x, and it makes it look kind of like what those sound waves were. So I could write an equation for those sound waves that we just saw, and it would have the sine and cosine in it and maybe something else, but some version of that. And so it's all connected together, right? All right. So back over here. Let's go to the page you picked up today. This is going on page 86 when we're done. And I'm going to remind you of this a couple of times, that a lot of what we've done so far, like logs and exponentials and quadratics and whatever, that stuff wasn't brand new to you. Fun chart, yes. But the other stuff, we took something you knew and kind of extended it. This trig stuff is brand new to you. And the only way you're going to truly understand it and let it stick is if you actually do your assignments and practice and ask questions and make sense of it, okay? Some of it's going to look hard, and it's not at all. It just looks intimidating. And I promise you, if you just give it a shot, you're going to be fine. But you have to put in the work. You can't just assume that you're just going to remember because I said it once in class. All right. So here's the graph of f. And this could be sine, it could be cosine. I don't know. They didn't tell me, and I don't care. It does say that it's a sinusoidal function. So that tells me that it's periodic. It's going to repeat for infinity going in both directions. But they gave me just 2 periods of it, and it's totally fine. I'm supposed to find all this stuff here. I think most of the time, if you're given a graph, the easiest thing and the best thing to find first, best is a matter of opinion, but would be the midline, because it's going to help you with everything else. Midline is literally in the middle. On this one, I feel like I could just eyeball it. It's not that big of a deal. So my midline is a line, so that is at y equals 3. Everybody okay with that? Amplitude is the distance from a maximum to the midline or from the midline to a minimum, either one. And I could do these. It doesn't matter which one I do. They're all the same. What is the amplitude? 3. Okay, so it has a vertical stretch of 3, vertical dilation. Period. You can start anywhere to figure out the period, but if you can start at 0, that usually is easier for you because your input values are have pi's and stuff in them. So if I start here, what a lot of you wanted to do on that last assignment before you even necessarily knew this was a sine or cosine function is you wanted to stop here for the period. Does that piece itself, is that the only thing that repeats? No. I mean, I know it looks the same down here, but I would have to literally just move over and stamp it. So I got to keep going to here, then it repeats. So I'm going from 0 to pi, which makes the period pi. We okay with that? One cycle. What are my input, my domain for that? And the frequency would be what? How are the frequency and the period related? Look at your other notes. It's the reciprocal. So the reciprocal of pi is 1 over pi. Remember, it takes pi units to get one cycle, or I get one cycle out of pi units. Same concept, different way to talk about it. Any questions at this point? All right, then I'm going to give you a minute or two. I want you to do this next one. You can talk about it with your neighbors. You should talk about it with your neighbors because I'm going to get some unvolunteer volunteers in a minute.
the actual values it gives me,
Mhm.
I just get exactly 0.25,
Mhm.
but then when I do like the
Okay, that's because, did you type that in?
yeah.
Okay, it's because you typed it in, and that number, there's more to it in there. Does that make sense?
Okay.
So you're fine.
So
I'm sorry.
just
So you
use
go
this?
with that. Yes, ma'am. Yeah. But that's why it's
Yeah,
off
I
a
was
little bit. Yeah. No, you're good. Hmm? No. Oh, sure. you are. Yes. Mhm. All right. Carlos, you can pick which one you want to tell me about and tell me about it. Which one you gonna pick? The midline? All right. What you got for midline? Y equals 1. Y'all agree with that? Yes. Okay. And I think it's good to have it drawn into. It can be very helpful. Thank you very much. All right. Lynn, which one you want to tell me about? Okay. And what do you have for amplitude? 2. Y'all agree with that? Yes. Okay, good. Now let me say something a little extra about amplitude. Is that clearly on here you can just count 100% fine. But there's going to be another way we need to look at it sometimes. So we know, if I know the maximum here is at 3 and the minimum is at -1, this distance here, I have 3 above the axis, 1 below the axis, so the total distance is 4. Does that make sense? The amplitude is half of that because it goes from the midline. So it might be that the midline might not be that easy to find on something. So then take your max and min, figure out that distance, and then half that distance is your amplitude. Okay, that's another way to look at it. Any questions about that? Okay, good deal. All right. Emiliano, what do you want to tell me about? Period. I'm sorry, it's what? It's pi halves. Y'all agree with that? Yes. We would start here. I'm going to go to there before I repeat. There's your period, pi halves. We good? All right. Valdo, can you give me the frequency? I feel like it's calling on the same people as yesterday. How are the period and the frequency related? They are what? Look at your notes from yesterday. Yes, very good. 2 over pi. Now, what I saw some of, and actually last period the person said 2 pi. And I said, well, okay, I had seen earlier in the day that people were trying to keep the pi in the numerator. So it would actually be the reciprocal. He said 2 over pi. I said, is that what you said? He said, that's what I meant. That doesn't count. I don't get to read your mind. I think he did mean to say that, and someone came out of his mouth. But like you literally flip the whole thing over. That's all it is. Okay, we good on that? Okay, good. Now here's the next one. We don't have a picture. Okay, so we need to kind of come up with one to help us with this. And I know most of you don't think the words in these are important, but they are. So it starts by saying the sinusoidal function. So could be sine or cosine. I don't know. I really don't care at this point. But it's called h of 0. We have a maximum point at this point. Then it says the first minimum after reaching this maximum occurs at this point. All right, so those words, the first minimum after reaching this maximum. Let me tell you why it's worded that way. I'm going to draw something that's going to look real bad. Don't draw it because I'm going to erase it. But whether it's sine or cosine, it's going to go on like this for infinity, but a whole lot prettier, right? So don't draw it. 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 And so they give me a maximum point. I don't know which one. Maybe they give me this one. Okay. And there's an infinite number of maximums, infinite number of minimums. And what they're by saying the first minimum after reaching this maximum means they're not giving me this minimum. They're giving me the first minimum after reaching the maximum. So it's like the next part. That's what that means. And that's important. Otherwise, we don't know how to figure this out. Okay. So I just wanted to kind of make that part make sense. All right. Now the rest that I write and draw, I do want you to do. Okay. So, we have sine, and we're going to do this because they're still new to you. Your little sine parent function looks like this. Your little cosine parent function looks like this. And even if they did tell me it was sine or cosine, I would still do the exact same thing I'm about to do. What it gave me that shows up first is the maximum. So since cosine starts with the maximum, this is the one I want to actually use to figure stuff out. And I'm going to draw it a little bit bigger so I have something to label. Okay, I know you don't have a ton of room, but you have enough room to do what we're going to do. Okay, then I'm going to label. So it says the maximum, this point here at the maximum, this is pi 8. This first minimum is at 3 pi negative 2. I have drawn one cycle of really either sine or cosine, depending on the transformations, but it's one cycle. If I'm starting here and ending here, that's where the whole period is, right? But if I start here and end here, how much of the period is that? Half. And that's the information I have that I can figure something out for, just from there to there. If I'm looking for the period, do I look at the input values or the output values? We're going horizontally, so it's input. I'm going from pi to 3 pi. So if I take 3 pi minus pi, I get 2 pi. So this distance here is 2 pi, which means the period is what? 4 pi, because that's only half of it. Okay. Questions about that? All right. What is the frequency then? 1 over 4 pi. Very good. Okay. So now I could do, I feel like when there's not a picture and you're drawing it, midline would probably come last, where if they give you a picture, midline would come first. I'm kind of doing these like in an opposite order of how we did the other ones. At this point, especially because these numbers could be not so pretty sometimes, I have a maximum, I have a minimum, right? This distance, what's the distance between the maximum and the minimum? 10. Because you got 8 up there and 2 down there, this whole distance is 10, right? And like the other curve that I gave you on a something you could write on one time, one of those dry erase things, I gave you a curve and it said X and Y axis exist somewhere. We don't know where, but they're somewhere. Kind of same situation here. I really don't even care where my X and Y axis is. I do know that my midline is kind of in the middle, and it doesn't even matter if it's accurate. But if I take half of 10, what information does that give me? Yes, what information is that? It's the amplitude. Because this would be 5 and this would be 5. Does that make sense to you? So then the midline, that helps you find the midline, right? Because if I do 8 minus 5 or negative 2 plus 5, either way, I'm going to be here at 3. So this would be y equals 3. Now, could you do it in any order you want? Absolutely. I just think if you struggle with like going through it step by step like that, it should kind of work for everybody. But if you kind of see it all at once, that's fine too. Some people are going to be better at that than others. Questions? Any questions at all? Okay. Okay, listen. How did I get 100? 3. Okay. So do you understand that this length is 5? Okay, and that length goes from the maximum to the midline, right? This y value is 8. So if I subtract 5, that means that this has to be at y equals 3. You get all that? Good question. Thank you for asking. Anything else? Okay. Flip it over. Does this look familiar? Yes. Now, we've already done this one way. I'm going to approach this a different way, so you need your listening pants on again, especially you two. All right. So we have this clock. We're going to talk back through it again, and then I'm going to kind of show you some ways that you can apply something to all of these, because some of them get a little bit more confusing than others. And they're all going to be wordy, so you just have to be big boys and girls and deal with it. Okay, the figure shows a large clock mounted on a vertical wall. Okay, the clock has an 8-inch long moving minute hand. So I'm going to go ahead before I read anything else and label. This is 8 inches. Y'all get lost in these when you read the whole thing, and then you go back and try and half read things and don't know what to label where. All right, so then the center of the clock is 120 inches directly above the floor. Here's the center of the clock. This is 120 inches directly above the floor. Oh, that says 12. Okay, hang on. 120 inches. Everybody good so far? All right. It goes on to say, at time t equals 0 minutes, the minute hand is pointed directly up at the 12. It's right here. So at time t equals 0, how far is the tip of that minute hand from the floor? 128. Everybody good with that? All right. And it goes on to say, however, the clock is not working properly and the minute hand is moving twice as fast as it should. The next time the minute hand points directly up at the 12 is at time t equals 30. So that means we've got around one time and we're back up here after 30 minutes, or 30 minutes. And so I got 30, 128 also. Everybody okay with that? So then another easy point to, and then it goes on to say, as the minute hand moves, the distance between the end point of the minute hand and the floor periodically decreases and increases, right? And if I know that here I am at 0, here I am at 30, well then this is halfway around. That would happen at 15. And what would this distance be? 112. Because 120 goes to the center of the clock. That's 8 inches long. This is 112. Do 120 minus 8. Everybody with me so far? Okay. You can just, actually, you can just leave them both there if you want. All right, so now, this one again, not that big of a deal to understand that 30 minutes for one rotation, okay? But sometimes it will be like, we got 5 rotations in 23 minutes or something like that, like the numbers get weirder or they're whatever. So again, I'm giving you a tool that will work on all of them. Usually when we make fractions, when we have time, it's like miles per hour or something, and time is almost always on the bottom. But we need to flip that over, and the time is going to be on the top. So we know that it takes 30 minutes to make one rotation. So we're going to put 30 minutes over one rotation. Okay? So every time you have one of these, you will have some sort of time that they have told you, or you can figure out how much time one rotation makes, or maybe how much time 5 rotations makes, or something like that. But you will put time over rotations every time. Now, before we go any farther, look at what we have here, okay? That same picture that you've seen a few times. We have 5 ordered pairs that we have to fill in. Sometimes we have to come up with more than 5 to fill in what we need, but we got to put 5 on there. And these 5 points chop the graph into 4 sections. Do you see how that is 4 sections? If you forget that it is 4 sections, you can go look at it and count, because you knowing that it is 4 sections is very important. Because then you're going to take whatever this is that you just came up with, and you are going to multiply it by 1 over 4. Okay? So then that means a quarter rotation, quarter meaning a fourth, quarter rotation, which from here on out I will use as QR for quarter rotation. Okay? A quarter rotation, when I multiply, that is 30 over 4. Now, I could totally leave it as 30 over 4. And there's absolutely nothing wrong with that. Sometimes you reducing it can make your life a little easier, or if it's super obvious, it's fine to do it. But in this case, I'm going to go ahead and make that 15 over 2. But I definitely don't want you reducing the fraction wrong and then it being wrong. But it does not have to be reduced. Okay? We all good with that so far? All right, so then now we are going to hang on to that. That's our quarter rotation we want. And we're going to come and make a little t table here. And we've got t, h of t. And I'm going to start at 0. And then a quarter rotation is going to be 15 over 2. And then each quarter rotation is going to be another 15 halves, which makes this 30 halves, this 45 halves, and then 60 halves. That's 5 input values. Again, sometimes I need more. We'll talk about how we know we need more, but I'm going to at least start with 5. Okay? And then I'll go ahead and fill in whatever outputs I know. I already know, we have figured out 0, 128. Now, can I reduce some of these fractions? Yes. Do I have to? No. I'm going to on this one just because I'm going to show you that sometimes it helps to be able to connect it to something you have, Or again, if you got 30 over 2, I mean, that is 15, and this is 30, but you don't have to. And I might not on any of the other ones. Okay? And so I know I have, because now I know at 30, I had 128, and at 15, we came up with 112. Okay? We all agree with all those? And just like I mentioned the last time we did one of these, was that the best thing to do first is to get all of your output values in there. I know that I got from the question my maximum value and my minimum value. So my maximum output is 128, and my minimum output is 112. Okay? Which means I then should be able to get the two missing outputs. What's halfway between 128 and 112? 120. I know that for two different reasons. Either I can do a little bit of math and figure out what's halfway between the two, or if I think about what's happening up here, I know that this is halfway, and I know that that's at the center, and they pretty much gave it to me, if I can wrap my mind around it, okay? When they score this, you get 1 point for correct output values. That should be a no-brainer, no matter what's going on with the rest of the stuff. We good on that? Then you also get 1 point for correct input values. Just start putting your input values in. You can't just start with 0 here every time, okay? Your first input value that you get to write down, you have to look at the outputs you have, which, I mean, I found the other ones. I can put 120 here if that helps. And then you look to see when is the first maximum output value, and it happens to be at 0. If they said, instead of it starting at 12, if it started at 6, then this would actually be my first maximum. So the first input value I'd write would actually be 15. But that's not what's happening, because this is the maximum. So I do get to start this one with 0. So I can put a 0 here. And then I just fill in the rest of what I have over there. This is 15 over 2. This is 30 over 2, or 15. This is 45 over 2. And this is 60 over 2, or 30. And you'll be able to split up no matter what kind of weird numbers you have. And like I said, we're going to do a bunch of these, because I want you to get all of these points every time. You should be able to do that without a problem. What questions do you have? Okay, beautiful. Now, what we didn't do the last time we looked at this is we didn't find the period, the frequency, the amplitude, and the midline, because we didn't even know what those things were then. Because I already have a picture, I personally think that the midline is the best thing and the easiest thing to find first. It is actually staring you in the face. What is it? Y equals 120. Okay. What is the amplitude? Do we look at inputs or outputs for that? Outputs, because it is a vertical distance, right? Vertical distance, so I'm looking at the outputs, and it is 8. When you actually do this, you will actually be told that you're supposed to be writing an equation, either a cosine or a sine function. And it doesn't matter which one it is, cosine or sine, because you have those numbers up there to count the period, start here and end here. And that is a horizontal concept. So you look at your inputs, and 30 minus 0 is 30. And then what is the frequency? 1 over 30. Very good. Oh, 30. What questions do you have? Okay. So now the last part says to find two intervals for which the graph of h is both decreasing and concave up. All right, so decreasing on what I have so far is right there, but decreasing and concave up is here, right? So the intervals, when I write intervals, do I write down inputs or outputs? Inputs. It's always intervals of the domain. So this just goes from 15 halves to 15. Okay? That's only one interval. It happens again right here. But I don't have any points there. But I can get the points there because I know the output here is 120, the output here is 112, but those don't actually help me with the answer. What would this input be? 75 over 2. So look, even if I reduced this to 30, it's good to have it not reduced because you see how you can just keep counting? This is 75 over 2. Then I add 15 to 75 and I get 90 over 2, which is 45, but I can leave it as 90 over 2. And so then this is 75 over 2, 90 over 2. Okay. What questions do you have? Don't overthink this stuff. Don't try to make it harder because it looks harder, because you can do these things, I promise. Any questions at all? Awesome.